What if I told you you're not just standing still right now, but you're actually flying through the universe at over 1,000,000 miles per hour? Sounds crazy, right? But buckle up, because Earth isn't just orbiting the sun. Our planet is part of a colossal cosmic journey involving swirling galaxies, invisible gravitational giants, and forces that could one day trigger another ice age, or even the extinction of life as we know it. So, before you click away, ask yourself this. How much do you really know about where you are in the universe? What you're about to learn might change your understanding of reality itself. And hey, if space and mind-blowing science are your thing, don't forget to subscribe to Curiosity Echo, hit that like button, and tap the bell so you never miss a cosmic beat. Now, let's zoom out. Most of us grow up thinking Earth just spins on its axis and goes around the sun. Simple enough, right? But here's the twist. The sun isn't standing still either, and neither is our galaxy. In fact, Earth, the sun, the entire solar system, we're all hurtling through space on a spiraling path that traces an invisible dance around the core of the Milky Way. It's like riding a roller coaster through infinity. Now imagine this. What if this wild ride wasn't just about motion? What if Earth's movement through the galaxy has shaped life, death, and even the climate of our planet? Let's dig in. Start with a mental image. You're inside an airplane, flying smoothly. You feel still, right? Now imagine watching that same plane from the ground. It's zooming by at hundreds of miles per hour. That's relativity. And Galileo figured this out in the 1600s. Your motion depends entirely on your frame of reference. So when we talk about how Earth moves, we first have to ask, compared to what? Relative to the sun, yes. We orbit it once every 365 days. But even that orbit isn't a perfect circle, it's an ellipse. That means we get closer to the sun at some points, what scientists call perihelion, which happens around January 3rd, and farther away at aphelion, around July 4th. But here's the kicker. Even the sun isn't sitting still. Thanks to the immense pull of the gas giants, especially Jupiter and Saturn, the sun actually wobbles slightly as the planets orbit it. This gravitational tug-of-war slightly shifts the sun's position. It's like a celestial ballet, and Earth is part of the ensemble. And that brings us to something big, really big. The Milankovitch cycles. Ever heard of them? These are long-term changes in Earth's orbit and axial tilt, caused by gravitational interactions with other celestial bodies. They occur over tens of thousands of years, and they've been linked to the onset of ice ages. Right now, Earth's axial tilt is about 23.5 degrees. But over a 41,000-year cycle, that tilt shifts between 22 and 24.5 degrees. And that tiny change? It affects how sunlight hits Earth's surface, dramatically altering global climate over time. Some scientists believe we may be overdue for another glacial period. But here's the twist. Human-driven climate change might be delaying it. So here's a question for you. Do you think we're actually holding back the next ice age? Or just making things worse in the long run? Let me know what you think in the comments. Let's go even deeper. You've seen models of the solar system, planets going around the sun, all neatly arranged. But that's a flat lie, literally. In reality, the solar system is moving, plowing through space in a spiral motion around the center of the Milky Way. Picture the planets trailing behind the sun like the tail of a cosmic comet. Earth isn't moving in circles. It's corkscrewing forward through the galaxy at about 514,000 miles per hour. And the Milky Way itself? It's not just a static disk of stars. It's rotating like a giant pinwheel, and we're part of one of its spiral arms, located about 25,000 light-years from the galactic center. But here's where it gets even crazier. The sun, along with the solar system, bobs up and down through the galactic plane every 60 million years or so. This up and down motion, called vertical oscillation, might be far more than just a fun fact. Some astronomers think it's tied to mass extinction events on Earth. Why? Because the center of the galactic disk is a dangerous neighborhood, packed with stars, radiation, and chaos. When we dip into that region, Earth could be exposed to higher levels of cosmic rays, damaging DNA, sparking mutations, and potentially wiping out entire species. Think about that. Your very existence could depend on our current galactic altitude. But wait, we're not done moving yet. Let's look at how the Sun travels through the galaxy. It takes the Sun about 230 million years to complete one orbit around the Milky Way's center. That's called a galactic year. We humans have only been around for a fraction of a galactic year. In fact, the last time the Sun was in this region of the galaxy, dinosaurs roamed the Earth. And our motion isn't smooth. The Sun moves forward, inward, and upward, drifting slightly in all directions due to the pull of stars, gas clouds, and dark matter we can't even see. Astronomers estimate we're currently about 75 light-years above the galactic plane, still drifting upward, but not for long. Eventually, gravity will pull us back down. Now, here's where it gets intergalactic. Our Milky Way isn't flying solo. We're part of a gravitational family called the Local Group, a cluster of over 50 galaxies, including our closest neighbor, the Andromeda Galaxy. And guess what? We're headed straight for Andromeda on a collision course. Don't worry, it won't happen for another 4 billion years. But that's not all. The Local Group is being pulled toward an even more mysterious region of space known as the Great Attractor, a colossal gravitational anomaly located about 150 million light-years away. We're rushing toward it at 373 miles per second, but no one's really sure what it is. A supercluster? A massive concentration of dark matter? A hidden structure? It's one of the biggest mysteries in cosmology today. And beyond even that, space itself is expanding. Thanks to the work of Edwin Hubble and many others, we now know that galaxies aren't just moving. They're getting farther apart as space stretches. It's not like galaxies are flying through a pre-existing void. The void itself is growing. This expansion is speeding up, driven by a force we barely understand: dark energy. So even as gravity pulls us toward the Great Attractor, the fabric of space is stretching everything apart. That's the paradox of cosmic motion. We're being pulled in while everything else moves away. To track our speed through all this, scientists use the cosmic microwave background, the faint afterglow of the Big Bang, as a reference frame. Compared to that, Earth is moving at a blazing 229 miles per second. So what's the point of all this motion? Some might say none. We're just cosmic debris caught in a gravitational tide. But others, like me, see meaning in the movement. The fact that we can measure, understand, and even predict our path through space is a testament to human ingenuity. It's a reminder that we're not stuck on a rock. We're part of something massive, dynamic, evolving. And knowing this changes how we see ourselves. So next time you look up at the night sky, don't just see stars. See the path, the speed, the history of everything. And remember this: you are not standing still. You are surfing the universe. If this journey through space blew your mind, make sure to subscribe to Curiosity Echo, hit that like button, and activate the notification bell so you never miss an interstellar update. And tell me in the comments, what surprised you the most about how Earth actually moves through the cosmos? I'll be reading. See you in the next video.